Okay, this is the second problem of mole fraction. The first one we did, we simply found the mole fraction. Now we're going to use the mole fraction. And so it's important to realize that the formula for mole fraction for this one is going to be Ki, is the moles of Ki over the total moles. And so what I'm going to do is, I don't give you part of the fraction, so I'm going to take this and make this my numerator over 1. So mole fraction of Ki means I'm going to have 0.25 moles of Ki over 1.00 moles total. Okay? So that's important to recognize that I use, if I'm given a mole fraction, I need to form this fraction right here. Okay? So, and it's asking for the mass of water. Okay? So, obviously, I need to find the moles of water. Okay? And so, in order to find the mass of water, since I only have units of moles, so the first thing I'm going to do is find the moles of water. And again, it goes back to the solution is basically the sum of the solute and solvent. So my total is 1 minus the 0.25 to give me 0.75 moles of water. Okay. And then simply to find the mass of water, okay, I'm going to use the fact that N of water is the mass divided by the molar mass. And so the molar mass of water is 18.02 grams per mole. So I have 0.75 is mass divided by 18.02. So to get rid of the fraction, I simply multiply both sides by the 18.02. So this is 0.75 times 18.02 is equal to mass. And the mass of the water is going to be equal to 13.5 grams of water. And that's all I had to do for that particular problem. Okay. Now, you also need to be able to convert between units. So this last problem is a good example of that, where I had mole fraction of Ki was 0.25. And from that, I ended up with 0.25 moles of Ki divided by 1 mole total. And so that's actually going to be the first step when I need to go from unit to unit. So I'm going to take whatever this numerator is here, and I'm sorry, whatever this is, and I'm going to make that my numerator. And for most of these, the molarity, the molality, and the mole fraction, my denominator is 1. Okay? Only in mass percent is it 100. Okay? And I could do 1, but remember mass percent, I have that times 100. And so I just make my denominator, or the bottom part of the fraction, the 100. So again, this is molarity. And you're really going to have to know this for the test. This is molarity with a R. This is molality. This is mole fraction. And this one is mass percent. And so molarity, molality, mole fraction are all over 1, and mass percent is over 100. Okay? Then I need the equation of where I'm going to, because if, again, I've stated this over and over again, if I don't know where I'm going, I don't know how to get there. Okay? Figure out what needs to be changed. Remember that density is the mass divided by the volume, and the molar mass is mass divided by moles. And so if I need to convert between mass and volume, I use density. If I need to convert between mass and moles, I use molar mass. Okay? So we'll do one problem. All right. it says calculate the molality. So it wants to know what my molality is. Again, this is how it's going to be given to you on the test. So I need to recognize the fact that this M is molarity. So I have a molarity. I write it out because it's very difficult to tell the difference between a small m and a big M unless I write them side by side. It's 2.50 capital M of NaCl. I have a density of solution of 1.08 grams per milliliter. And I went on and gave you the molar mass of sodium chloride as being 58.44 grams per mole. Okay, so step one was to take in the given amount and make it a fraction. So that means that my molarity is, I take whatever number's given and make that the numerator, 2.5. And remember, that's my moles of solute, so that's moles of NaCl. And molarity is over 1, so this is 1. The units of molarity is liters, so liters, and this is of solution. So that was step 1. Step 2 is to find to write down the formula of what I'm going to. And I'm going to moles, there's no numbers in step 2, of NaCl per kilogram of, we're going to assume, unless it says otherwise, that the solvent is water. So kilograms of water. So no numbers in step 2, only in step 1. And then I look, okay, so, and if you want to, if it helps, you can write down the fact I have moles of NaCl is 2.50 moles, of course. I have a volume of solution is 1.00 liters. So if you want to make that, take this fraction and make a list of variables, you can do that, okay? So I already have my moles of sodium chloride. What I do not have is the mass. And so basically all of this calculation is going to be going from volume of solution to mass of water. Again, solution and water are not the same thing. Solution is solvent and solute. So always remember that this is a very important concept in this chapter, that solution is solute plus solvent. And most often we talk about it in volume. Okay, so since I have solution, I'm going to use my density. So the first thing I'm going to find is my mass of solution. Okay, and so the formula is density is the mass divided by the volume. So the density times the volume is equal to the mass. So mass is going to be equal to the density, which was 1.08, times my volume, which was 1.0. Oh, I'm like, that doesn't look right. Okay, this is in grams per milliliter. This is in liters, so it has to be in the same unit here. So that is 1,000 milliliters. So that gives me 1,080 grams of solution. Now going back to this formula, I now have this. I need this, so I need to find the solute. Okay, so what I have of the solute is the fact that it's 2.5 grams. So I need the mass of NaCl. Okay, and that is moles is equal to mass divided by molar mass is the formula that I'm going to use there. So I have 2.50 is the mass times the 58.44. So 2.50 times 58.44 gives me, I have it written down, 146.1 grams of NaCl. Okay, so now I have this and that. So this is 1,080 grams. This is 146.1 grams plus the mass of water. So 1,080 minus 146.1 plus mass of water. I don't know why I rewrote that again. Hold on. Just making a mistake here. 1080 minus 146.1 grams is equal to the mass of water. So the mass of water is going to be 933.9 grams of water. Now, in order to plug it into this equation, it has to be in kilograms. So this is equal to 0.93, I'm writing really badly, down here at the bottom, 339 kilograms of water. Okay, I'm going to change colors just because of the fact that where I am is very difficult to see. Got a blue. All right, so my molality is going to be the moles of sodium chloride. So I already had that. That was the 2.50 moles. Divided by the kilograms, which is 0.9339. And so my molality is equal to 2.67. And that is molality. I said I was going to write it out, but I ran out of room. Okay? And so I will do another example of that in the next